Hi there, welcome to lesson 3. Today we're going to talk about functions. We're going to go over these particulars that you see up front right here. Not too sure about the last 3 though. Well, we'll see how the lecture goes. So first let's talk about the function as far as definitions go. A function, and you can read all of this stuff and read it to yourself, but the way I like to think of a function is I like to think of a machine, meaning I put something into X and get a exact known value for Y. Meaning, if I put if I put the number 1 into the machine, I get a 100% certainty on, let's say, a 3. A 3 comes out. I know for a fact a 3 comes out. Not multiple things come out, just a 3. So a function to me is a machine. It's a relationship between X and Y, where for every X I get one exact Y. I do not get multiple Y's. I just for every X I get one Y. However, multiple X's could give you the same Y, but that's another thing. I'm going to talk about the machine, and then we'll have a better idea. The domain of a function is what X could possibly be without making the function go crazy. So if we had a fraction, then we know a fraction cannot be divided by 0. So it would not be within the domain if that number would make the denominator go 0. So for the domain pretty much is any number that doesn't make the function go undefined. And the range is pretty much where we get out of the machine. It is what we get when we plug in for X. So that's within the domain. So if I put a number from a domain into the function, then I should get a number which is within the range. However, if I put a number that's outside the domain into the function, then that number might not be in the range. It could be in the range due to a number that is within the domain, but that might not happen. So let's talk about the machine. Before we talk about the machine, let's talk about independent dependent variables. We like to call, it's human convention that we call X the independent variable and Y the dependent variable. And that's because we like, for some reason, some guy started this saying that, okay, let's have all of our students learn that we're going to have Y equals 3x plus 5. I mean, I could totally mess things up if I went back in time. I could like stop that guy and say, okay, from now on we're going to have, let me actually have black. From now on we're going to say X equals 3Y plus 7, you know. I could have like started this whole revolution, and then X will be the dependent and Y will be independent. But that's not what happened. I cannot go back in time, therefore I cannot change things. But I actually like the way it is, because it goes X, Y, Z, so we're starting with X and then it goes to Y. So to kind of graph this function, we have this X and we have this Y, and we could use numbers like -2, -1, 0, 1, and 2, and we could get corresponding Y's, meaning that if I plug in like -2 in there, I could get -1 because that's -6. -1 would give me 2, and I kind of see a relationship because it's going to continuously increase by 3, so kind of it's going to be like that. Now, had the function looked like this, then I believe it's fair to say that Y is independent and X is dependent. And the reason why I would say that's because I would first have to input something for Y in order to get X. So X is waiting for me to put something into Y so I can solve what X is. So X depends on Y. But we're not going to talk about that now. This is going to be when we go over inverses, and then we're going to have a lot of fun. So let's go back to our presentation. So X is the independent, Y is dependent. That's what we like to say. So let's talk about testing for a function. Now, I like to think of a machine because let's say we have these two functions, right? We have function 1, we have function 2. Let's say, and that they both are with the variable x, y. So function 1 and 2 depend on x and y, right? And let's say this function is really just a set of numbers, set of points, meaning I could have something like this happening. And now I have to kind of think because I'm trying to set this up in a certain way. Let's say this is 1, 2, and this is like 3, 4, and let's say that's like 1 and 5. Now this is not going to be a function, and let me tell you why. Us human beings, we like to be certain. We like to be very certain. We are very careful creatures. We like to know everything. So if a function pretty much has to give us certainty. In this case, if you look at this, if you focus your attention towards this point and this point, you can see how I can put the number 1 in here, and I can potentially get 2, and I can potentially get 5. Now that causes me an uncertainty. Let me erase. This is bothering me. I don't know why I'm this way. I don't know why this bothers me. That it really does, and doesn't even erase it completely. Anyways, I input a 1 and I get a 2 and I can get a 5. So that doesn't give much certainty, because if I do my calculations and I do my little table and I put 1 in here, then I can get 2 values. And that's why this is not a function, because this is uncertain. I need to know exactly what happens when I put 1 in there. Otherwise, I'm not going to give you the privilege of being called a function, and then function 1 is going to go in its room and start crying, you know. I don't know. Anyways, this is not a function. Now, things are not that fair in this world, and let me tell you why. Let's say we have another, and now I have to think again because I'm trying to set this up correctly. By the way, I forgot commas here. And let me just make the commas now so I don't forget them later. Let's say I have a situation where it's like 1, 2, and then 3, 4, and this time I have 5 and 2. And let me tell you this. This is actually a function. And I know you're looking at this, but Mr. S, this has a y being 2 and this has a y being 2. Last time when I had 2 x's yield 2 different y's, wouldn't it be fair to say that this should also not be a function? Because now one y yields 2 different x's? And the answer is no. Again, us humans, we just care about being certain. Now, if I put a 1 in there, I know for a fact that I'm going to get a 2. So I'm happy. If I put a 5 in here, I know for a fact that I'm going to get a 2. So although 1 and 5 both yields 2, this is still a function because along the line I always knew what I would get if I plugged in a 1. That would give me a 2, and I always knew that when I put a 5 I get 2 as well. So this is a function. So function 2 is indeed a function. Function 1 is not. So you can see how this gives you uncertainty, because when you put something in you get 2 different outcomes, right? And over here it's not the case. It's like saying if I do this action, something good might happen or something bad might happen, assuming 5 is bad and 2 is good. But in this case, if I do this, something good happens. If I do this, something good happens. I know that something good's going to happen to me if I do either one of these two. You know? It's like doing the dishes for your wife. Something good is going to happen. And then maybe letting your wife decide what kind of TV show you're going to watch, and something good's going to happen. Anyways, so that's one way to test for a function. Now another way is called the vertical line test. And the vertical line test is probably the easiest one to kind of remember. This right here could be a function, right? As a matter of fact, it is a function. And the reason why I know that is because I can draw a vertical line at any point I don't get to change my color? Okay, I guess I do get to change my... Why do I not get to change my color here? Whatever. I make a vertical line and I only touch the function once. Therefore, it's a function, according to this line right here. I make a line here, it's still a function. As a matter of fact, I can make any vertical line I want, and I would still have a function, because there's no point on this graph at which, when I graph a vertical line, I hit the graph twice. And since I'm only hitting it once, it's a function. If I would have hit it twice, then it wouldn't be a function. For example, if I made a sideways parabola and I made a vertical line, you can tell that I'm going to hit the graph here and here. That is not a function, because it fails the vertical line test. Vertical line test and vertical line test. Alright. Now another one could be like this. You could like have something like this happen. That's definitely failing the vertical line test. Like that's like complete fail. I mean that equally not lines. But that's what the vertical line test does. You pretty much draw a vertical line at a graph, and then you check whether it hits it once. If it hits it only once, it's a function. If it hits it more than once, it's not a function. And let's do this. Let's leave it at this. Let's do this slide and then call it a day, because I feel this is taking way too long. Let's do a new page. So we have g of x equals. I like these changes. I don't like staying traditional. Instead of always calling f of x, writing g of x is actually a nice change. Negative x squared plus 4x plus 1. And then we're trying to find out what g2 is. G2 is, you pretty much just plug in 2 into there and solve it out. So wherever I see an x, I put a 2. So when you solve this out, you get negative 4, you get 8, and you get 1, which gives you 5. Bam. So g of 2 equals 5, and you can also represent it as a point, 2, 5. This is a point, and you can write it either way. The other one I believe was g of something else, g of t, and g of t just means that instead of having an x, I'm plugging in a t. There we go. And then we can simplify it to negative t squared, because t times t is t squared, plus 4t plus 1. Bam. It looks a little bit ugly, but you get the point. And then if the last but not least is g of x plus 2. Now I don't mean to impress you too much, but what I'm about to do is going to be very impressive, because I'm pretty much have mastered squaring a binomial in my head. And you'll see x plus 2 plus 4, and then wherever the x is, I plug in x plus 2, and then plus 1. So wherever there's an x, wherever there used to be an x, I put the x plus 2. I did forget to put this 2 here for square though, so that's not that impressive. But the average person, and you know Mr. S is not average, would probably like FOIL this out, but Mr. S knows how to do this in his head. This is going to be x squared, this times this is 2x times 2 is 4x, and this is going to give you the 4. And then we have plus, and then when you distribute the 4 inside, you get 4x plus 8, and then plus 1. I know what you're thinking. How is this man doing this? You know, I'm asking this question to myself sometimes too. I mean, I am so gifted. This is going to give us a negative 4x. This is going to give us positive 4x, so that just goes away completely. That's negative 4. That's a positive 8, which is a 4. Plus 1 is 5, so plus 5. And there we have it. G of x plus 2 is negative x squared plus 5. And I think that is it for today. I'm not sure if I want to do anything else. Should I squeeze in? I don't know. Nah, I'm not gonna do that. Yeah, let's call it a day. Anyways, you guys have a fantastic day. Bye.